Welcome. In this session, I am going to discuss chirality in drug substances, polysaccharide stationary phase and principle of separation. Chiral separation is one of the challenging tasks for the chromatographers. That is the reason I decided to share my skill-based knowledge on these topics. Lectures have been made in sequential and progressive way for better understanding of the subject and will be delivered in several sessions. I would request to watch all the lectures in a sequential way for better implementation in routine work. Let's start the session. In this session, you will learn why chiral separation is required, what was the thalidomide tragedy, what are the different chiral phases, what are different polysaccharide chiral stationary phase, why polysaccharide stationary phase is preferable choice for separation, what are the different forces responsible for separation, what is the separation mechanism. Why chiral separation is required? Thalidomide tragedy is one of the darkest episodes in pharmaceutical history. Thalidomide drug was marketed in 1957 for treatment of pregnant women developing morning sickness. It caused thousands of babies worldwide to be born with malformed limbs, that is phocomelia, and only 40% were survived. The damage was revealed in 1962. It took about 5 years' time. This negative effect of thalidomide led to the development of more structured drug regulation and control over the drug use and development. More than 80% APIs are chiral in nature. Compounds in our body is also chiral in nature. Chiral compounds having unique characteristic of showing handedness means inclination towards only one form. Initially, chiral APIs were not prepared in optically pure form due to various limitations. Means at that time there was not analytical techniques available. Means there was not any chromatography techniques available. The enantiomer of APIs may be biologically active, inactive, or harmful. Thalidomide is a chiral molecule and initially it was manufactured in racemate form and not in pure form. Means in thalidomide there was 50% R form and 50% S form. Its R form is biologically active whereas S form is teratogenic in nature, and phacomelia was due to S form. Basic principles. Chiral separation is based on like interactions, like principle. Same as left hand glove fit well only in left hand and cannot in right hand. Right hand can only shake right hand and cannot left hand. That is also called handedness. Separation of chiral isomers occur via weak interaction between the groups present on the molecule and stationary. Chiral stationary phases. Types of chiral stationary phases. Polysaccharide derived. It is available in both coated and immobilized form. Chiral crown ether, Pringle based, antibiotic based, cyclodextrin based, protein based. Today we will discuss polysaccharide based stationary phase only. Polysaccharide chiral stationary phase. A polysaccharide is a large carbohydrate molecule. It contains many small sugar molecules that are joined chemically. Polysaccharide stationary phases are based on chiral selectors produced by derivatization of amylose or cellulose polymers. Amylose is a straight chain polymer in which alpha 1,4-glycosidic bond exists between D-glucose units. Cellulose is a straight chain polymer in which beta 1,4-ester bond exists between glucose monomers. These are the structure of amylose and cellulose. Chiral selectors. Polysaccharide derived chiral stationary phases can be classified into cellulose ester derivative, cellulose carbamide derivative, amylose ester derivative, amylose carbamide derivatives. More than 90% of various racemate can be separated on above phases. These derivatives of cellulose and amylose are highly used in separation of chiral molecules in both reverse phase chromatography mode and in normal phase chromatography mode. These are the structures of carbamide and ester derivative chiral selectors. When isomers are non-superimposable mirror image of each other, then isomers are called enantiomer. Here, S form is non-superimposable mirror image of R form and R form is non-superimposable mirror of S form, and that is the reason these are enantiomers of each other. Chiral stationary phase interact differently with each enantiomer and forms transient diastereomeric complexes through the following forces. These are hydrogen bonding, pi-pi interactions, ionic bonding or dipole-dipole interactions, steric interactions, and hydrophobic interactions. We are going to discuss these forces in details in next slide. Now question comes, in which case separation will take place by dipole-dipole interaction or hydrogen bonding or by pi-pi interaction. For separation via dipole-dipole interaction and hydrogen bonding, each stationary phase and chiral molecules must have functional groups like NH, carbonyl, and OH groups. Pi-pi interaction takes place between pi acceptor aromatic ring and pi donor aromatic ring. Here, NH groups and carbonyl groups are capable to form hydrogen bonding and are also responsible for dipole-dipole interactions. And any chiral molecules with functional groups like that can interact by these forces and isomers can be separated. Here, this aromatic ring is pi accepted since nitro groups are electron withdrawing groups. Therefore, any chiral molecules with pi donor aromatic ring can interact and its isomers can be separated. The above interaction of chiral stationary phase with each enantiomer is not the same and hence each enantiomer has different retention at the chiral stationary phase and each isomers are getting separated. The isomer that is less retained on the chiral stationary phase elute first and the isomer that is more retained on the chiral stationary phase elute last. Here S isomer is less interacting with the chiral stationary phase. That is the reason it is eluting first. And R isomer is more interacting with the chiral stationary phase and that is the reason it is eluting at last. For any questions related to this lecture, please write in the comment section and I will answer on priority basis. If you are new on this channel, please subscribe to this channel Thank you for watching this lecture.